Physics is usually sold to us as a nice, safe package. Apples fall down. Planets go in circles. Time marches forward. Tick-tock, tick-tock. It feels stable. It feels polite. But here's the thing. Physics isn't actually about apples or planets. It's about the source code of reality. And just like any code, if you stare at it long enough, you start to see the bugs, the glitches, the things that shouldn't be there. This is the physics iceberg. We're going to descend from the weird to the scary, down to the absolute nightmare fuel that some physicists genuinely hope is wrong. Some of these ideas might explain why you feel like you're glitching out today. Others suggest the universe could delete itself before I finish this sentence. And a few suggest that you don't even exist. Let's start at the surface with something we think we understand. Time. The standard example is the twin paradox. You know the drill. One twin stays on Earth. The other blasts off in a rocket at near light speed. When the space twin comes back, he's younger than his brother. Not looks great for his age younger. Actually younger. His watch ticked fewer times. Why? Textbooks usually give you some dry math about relativity. But I want you to picture it like a video game. Imagine the universe as a game engine with limited processing power. You are constantly moving through two things, space and time. But the engine has a strict speed limit, the speed of light. If you use all your processing power to move through space at max speed, the universe has no power left to render your movement through time. So, your personal frame rate drops. You start lagging. To you, on the ship, everything feels normal. But to the universe server, you are glitching out and moving in slow motion compared to the rest of the map. We have actually proved this. We put atomic clocks on fast jets, and they came back slightly behind the clocks on the ground. Reality literally cannot handle you moving that fast without breaking its own clock. And that's just the shallow end of the pool. Let's go deeper. Imagine a box. Inside is a cat, and a vial of poison that might break based on a random radioactive trigger. Until you open that box, quantum mechanics says the cat is not alive or dead. It is mathematically both. Now, most people treat Schrodinger's cat like a funny meme. But stop and think about what it actually implies about you. It implies that reality is not solid until you look at it. At a quantum level, the universe behaves like a video game that only renders the room you are currently standing in to save memory. Before you look, it's just a cloud of probability. A maybe. The moment you look, snap, the universe makes a choice. Which leads to a creepy question. Why does the universe care if we are watching? Is reality objective? Or is it just a performance that puts on a show whenever it notices an audience? At the surface, this is just weird science. But down here, it feels like the walls of reality are thin. Now we leave the textbooks behind. This is where physics stops being fun trivia and starts being unsettling. Look at the night sky. Billions of stars. Billions of planets. Statistically, the universe should be a crowded, noisy rave of alien civilizations. But we hear nothing. Just static. Why? Well, meet the dark forest theory. Imagine the universe as a dark forest at night. It isn't empty. It's full of armed hunters. But every hunter knows that if they light a fire or shout hello, they become a target. In this theory, the silence of the universe isn't because we're alone. It's because everyone else is smart enough to shut up. We are the only idiots shouting into the void, sending out radio waves and maps to Earth, while the rest of the galaxy is hiding in the bushes, praying we don't get noticed. It isn't peace. It's terror. If the aliens don't get us, physics itself might. This is called vacuum decay. Right now, you, me, and the atoms in your screen exist in a specific energy state. Think of it like a ball resting in a valley. It feels stable. But math suggests we might not be in the true bottom of the valley. We might be on a little ledge, halfway down. If a tiny part of the universe randomly decides to slip down to the real bottom, it's game over. A bubble of true vacuum would form. Inside this bubble, the laws of physics are different. Atoms can't hold together. Chemistry stops. This bubble expands at the speed of light. You literally cannot see it coming because it moves as fast as the light you see with. 1 second, you're watching YouTube. The next moment, Control-A, delete. No pain. No explosion. Just gone. And the worst part, it might have already started a billion light years away, and the deletion wave is just rushing toward us right now. Sleep tight. We have reached the bottom. This is the point where physics sounds less like science and more like a psychotic break. It's called the Boltzmann brain. Here's the logic. Entropy says the universe loves chaos. It is very, very hard to organize atoms into a star, or a planet, or a human. It is statistically much easier for random atoms to accidentally bump together and form just a brain. A single conscious brain, complete with false memories. Memories of a childhood that never happened. Memories of a family that doesn't exist. And a memory of clicking on this video 5 minutes ago. The math says that in an infinite universe, these freak accident brains should be way more common than real, evolved humans. So, what are the odds that you are a real person, sitting in a real room on a real planet, versus the odds that you are a temporary brain floating in deep space, hallucinating this entire life for a split second before you dissolve back into soup? Physics can't prove you aren't. It just shrugs and says, probably. And finally, the idea that ties it all together. The simulation hypothesis. The idea that reality isn't base level. That the universe is just a program running on someone else's machine. If intelligent beings tend to create simulations, and if simulations can contain conscious minds, then simulated minds will vastly outnumber real ones, which means statistically, you are probably simulated. This would explain a lot. Why the universe runs on math. Why reality has limits, like a pixel size or a frame rate. Why the laws of physics feel more like code than nature. If this is true, then free will becomes uncertain. Meaning becomes fragile. You are real, but only because the program hasn't ended yet. From time lag, to silent forests, to the possibility that you are just a hallucinating space brain. Physics doesn't exactly promise comfort. It promises the truth, or at least the code underneath the truth. And sometimes that code is terrifying. But hey, even if the universe is a simulation, or a dark forest, or about to delete itself, you're still here. You're the part of the universe that opened its eyes and started asking questions. And honestly, that's pretty cool. Thanks for watching. And if I don't dissolve into a vacuum bubble, I'll see you in the next one.